That's 14.
Negative 2x plus 14. That's 14.
We've got minus 2x, okay, and then we're gonna have plus. I'm gonna just do one step at a time. Plus 14 equals 12.011. So all I've done is combine those like terms. I take 12 plus negative.
Yeah, I'm saying the same thing.
Okay. Now I'm gonna take this minus. I'm gonna take that 14. I'm gonna subtract it from that side. So now I'm gonna take minus 14 over here and minus 14 over here, and we're going to get minus 2x equals, what's this?
So negative 2.011.
Yeah, negative 2.011. Yeah. And so now we just divide by negative 2. And so our x is, what's our x? Whatever that x is. Negative 2.011 divided by negative 2.
That's 1.0055.
0.005.
Yep.
Are you sure about this whole?
No.
I think there's an
12.011
error here.
minus 14 is
It's
negative
5.5.
1.989.
That's what I thought. Negative 1.99.
989.
Oh,
Which, how many steps?
989. Right. So this part was an error here. So 12.011 minus 14 is negative 1.989, and divide that by negative 2.
Negative.
Wait, I can't see.
0.9945.
Yep. 0.9945. Right. 0.9945. Okay, so that right there, that x means that percentage, let's go over here, that percentage for that carbon isotope is 99.45%.
That's not what it was.
I know, because I changed the average mass, so it wouldn't be such an easy problem. Okay, so I changed the average mass. Go back to the video and check it out. This is 99.45%.
What was the average
Right
before? 12?
And so now the remainder is what for this? It's 1
0.55.
minus. Whatever. Yeah, it's going to be 0.55%. 0.55% for this guy. Okay? That's it. Now that's the hardest kind of problem I can ask for isotopes and average atomic mass. If that one doesn't make sense to you, think about, let me just give you a hint. Think about why I put a 1 right there and not a 100. I put a 1 right there because these are the decimal forms already of percentages.
Is it always a 1 right
All
there?
I'm trying to do right now is I'm trying to figure out what the percentage of one of them is. And so since I can figure out the percentages of one of them, I know that this one is going to be whatever 1 minus that percentage is. So for instance, if this one is 0.9945, this one's got to be 0.0055. And when you change that back into percentage, it's going to be the 0.55%
Wait,
of that.
is it always a 1 though?
It's always a 1. This is
So
always
if
going
you
to be
gave us carbon with 35 and 38, I plug in 35 for the 12s and 38 for the 14ers, and I can just them.
Say it again.
If you gave us the same thing, but the atomic mass for the first one was 35 and atomic mass for the second one was 38, I can just plug in 35 and 38 at the same time.
Yeah, but this average mass is
Yeah,
going to be different then, yeah. It's the same problem every single time. Okay, gamma, alpha, beta. Let's talk about that. Gamma, alpha, beta. What is an alpha particle? Does anybody know?
What is the least energetic one?
That's right. Least energetic. Looks like that, a fish. Least energetic. Least energy. Shielded by paper. What else? If I write this down, does that make sense?
Yeah.
That right there?
That's what it is.
That's what it is. Okay, that is an alpha particle. Right? I think so. So if I write an equation like this, if I say, which element should we use? Teddy, what do you think?
Boron.
Boron, okay. So boron's element number 5, I think. 5. And it has another 5 neutrons. So I put a 10 up there. Let's say that boron undergoes alpha decay.
So you automatically have to put that helium.
So you know that it's going to be spitting out. It's going to be spitting out an alpha particle. There's the alpha particle right there. That's alpha.
6 and 3.
Okay, and then the remaining is going to be what? You said it, 6 and 3. So that 3 means that this element over here is a lithium. I knew that just because I know what the third element is, but you would know that because you looked it up in your periodic table.
So we're going to periodic table wrong.
Yes. Okay, and I'm also going to show you what
Are we gonna get
you
what-
get on your formula sheet, because I know that's the question you're going to ask.
Yeah.
So here it is. I'm going to show it up to the camera so you can look at the camera. Ready? Camera, 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 camera.
Are we gonna get like what alpha and beta and gamma?
This is what you
equal?
get. You get that, and then on the other side, you get the periodic table.
Wait, what's that paper in between?
Okay, the paper in between is the test.
Oh.
Okay.
What? Get hey,
Ha!
hey, oh, I'll be back.
Wait,
Okay.
so we don't get like what alpha beta?
Alright,
You don't get that. That's right. So since you didn't see it, it's not on there.
Huh?
You have to know what alpha, beta, and gamma are. This is alpha.
When do we need like giga? There's-
Well, maybe when you have to convert something. Maybe.
What's that?
You always need to be able to convert things. I could always throw in a conversion problem. So we've done alpha. Let's talk about beta. Beta, I'm going to write in blue. That's alpha. Let's do beta. So beta is what? The medium energetic, medium energy. You write it like this. It's an electron. Okay. So let's do the same problem with boron. So we've got boron. Let's say boron now undergoes beta decay. It spits out a beta particle. All right. So we can do that. We can put this little beta right there. Pow. Check it out. There it is. So now the remaining element is going to be what? That's 0.
10, 4.
10, and what's going to make this
4.
equal on this side? What's going to make this
6.
equal on this side? Oh, yeah, 6. So now it's changed to carbon. Look at that. 6. So look at on this side, and it's always an equal sign right there. So -1 and 6 equals 5. All right? So you should be able to do any of these kinds of little equations like this. Where the bottom side is always, the bottom is always going to have equals. Let me say this again in a more clear way. For both the number of protons and the overall mass, each side of this reaction is going to equal each other. Okay, so this side is going to equal this side, that side is going to equal that side. Okay? And you can always figure out which element it is by looking at the number of protons. All right. And then finally, moving on into the last kind of radioactive decay, let's talk about gamma. Gamma. Gamma looks like this. This is gamma. Gamma is the most energetic. It's shielded by what? We didn't talk about beta's shielding.
Lead.
Yeah, this is shielded by lead. Betas, by the way, was shielded by aluminum. So I'll write that there.
And lead.
Shielded by, yeah, of course. Shielded by aluminum. That's the minimum amount. Okay. Now, gamma's equations are pretty easy. Right, Teddy? Stinks.
Right. Can I just come up here and say the camera?
We've already done it. Hi. Okay. Now,
I love Chloe.
gamma looks like that, right? There's nothing. There's no mass. It's just gamma. It's a gamma particle. So the remaining element is going to be what?
Same thing.
It's going to be the same. So it's going to be boron. There we go.
That's just great.
Isn't that awesome? That's totally awesome. I think it's pretty awesome. What do you think?
I think it's pretty awesome.
I think it's spectacular.
Spectacular.
Almost as cool as Darwin, but not even close.
That's
Wait,
right.
he has 100 like ringing Darwin.
We should see Darwin in a tie. He dresses up for the holidays.
Is he really?
Yes, he does.
Or do you dress him for that?
No, he dresses himself. He's a fancy cat.
Every day he dresses for work.
He's got this little plaid tie. He needs to get more in his wardrobe. That's all he's got right now, is a little plaid tie.
I feel like you actually have a flat tie, bro.
He's got one for himself. He bought it. What else should we talk about? Let's talk about radiation equations.
He's a model, right?
You mean radiation? Oh, that's what we just did.
Himalayan mountain wolf.
Fission fusion. He's not a mountain wolf. He's a cat.
Himalayan mountain dog.
Let's talk about fission fusion. Fission fusion. Fission is what? Division. When you take one atom, split into two. Fusion is a union, where you take two atoms, bring it together to one. They just combine. They go into one.
That's easy.
It's pretty easy. It's insanely easy.
It's just like straightforward.
It's totally straightforward. But you'd have to identify an equation that has, let's say, I'll give you an equation. You tell me if it's fission or fusion. Ready? Are you ready?
No one call out.
Okay. Let's do this. Think about it. Let's say 4, and we got this, and then we have lithium. Let's have that be 6. Let's have that be 8. And then let's go over here and say, oh my God, we're gonna have. Oh my God. Oh my God. Okay, we have 1 coming over here,
It's 2,
and then we're gonna have 2, and we're gonna have what's another? We need 7
7.
altogether, so it's gonna be 4. So it's gonna be
That's
beryllium,
fission.
and we're gonna have
Don't call out.
this,
Sorry.
and then the top part. Let's say this is gonna be
Yeah, it's fission.
the 8, and let's have helium. Have that be 4, and this is gonna be what's the remainder? Gotta be here. That's gotta be 2. Okay. So that's really heavy hydrogen, but that's okay. All right, so this overall is what?
Fission.
Fission, right? Because
Fission
it's
is
kind of
division.
weird. You start off with 2, but over here you've got 3, so it must mean one of them split, right? This is kind of a tricky question. But if you can
Wait,
figure
it's
out that
fission
this
is one of
is
the split?
fission,
Yeah, because fission
If
is
this is
Oh,
divided.
fission-
I thought fission would be like it was an 8 and it became into a 4.
but in this case you've got 2 things. Now they've gotten to 3 things. So that means one of them must have split.
It's like
So it's probably the lithium that split,
different ways out of 10.
right? Right. Now look at this. Check this out. I'm gonna do something crazy. Are you ready for this?
Dun, 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 dun.
You bars.
Pow! Now what kind of reaction is it?
Fusion.
Fusion, that's right.
I don't get it.
Because
I know you don't.
fusion, you put it
You-
together.
I switched the arrow. Look,
I get
3
it.
going into 2. That must mean that 2 of them combine into 1. So that is fusion. Cool, huh? Right. What equation is used in a nuclear power plant? Is it fission or fusion?
Fusion.
Fission.
Fusion.
Try again.
Fission.
That's right.
Oh.
Good job. It's fission.
You know, I guessed and it was a 50-50 chance.
That's right.
God really screwed me over that time.
So fission is what they use. Which gives a bigger boom? Fission or fusion?
Fission.
Fusion does, that's right. More mass of a fusion reaction is turned into pure raw energy. Yeah. More of the mass in a fusion reaction is turned into pure raw energy. Right. Okay. What else do we need to know about? We need to know about half-life.